had happened over time is, in fact, there's no 4th edition because no one could agree on what was supposed to happen. So we went from a 3 to a 5. The size of the spec revisions started becoming so large and were so controversial that they wanted to change the whole process. And 6 was the last huge revision that we will hopefully ever see, and it was massive. But the way it works now is anybody can propose changes to the language. They get an official sponsor from the committee who then takes it through, writes up a formal spec, things like that. And if it meets certain criteria, it keeps moving through the process. And one of the criteria on the last stage, which is to get to stage 4, which is ready to be ratified, it has to have 2 non-transpiler implementations. So that basically means 2 browsers that have implemented that feature, and those features can't be behind a flag. So it just has to work in at least 2 different implementations to get there. So that means that ES7 is getting ready to be ratified, and we know exactly what's going to be in it. And it's exactly 2 things. It's really small compared to everything else. So that process works. But ES6 was the last huge one. And so all I'm going to talk tonight about is probably 5 of my biggest highlights, and we'll take questions. So if you have specific questions about things in the language, feel free to ask me, and we'll go off script and go there. But I wanted to talk about that tonight, where to go, because you can get lost in it in a hurry. The first question people ask is, where does it work? And the answer is, Node.js is an easy win. You can use ES6 inside your build scripts all day long right now, and there's a lot of good reasons to do that. And then the other thing is all the latest browser versions, and that's about it as far as native support. So the latest version of Chrome, which just came out, supports like 99% of the features. Firefox, the nightly build of Safari is great support. Edge has excellent support. Internet Explorer has no support and will never have support. So why do you care? Well, asking myself that question, I came around a great quote. We want to write code that makes it as easy as possible to understand. And the 6th edition of the language really provided some ways to make code much more maintainable, much more readable. Really kind of laid out clearly where you can write code exactly how you intend and someone else can read it really easily. So it makes it much more maintainable. So how do we reconcile this with the fact that it only works in the latest browser? There's a process, and we're going to explore it later at the end, called transpilation. So it's different than compilation in that we're not fully compiling the language. We're simply translating syntax to a lower language spec level. And so most of the features can go all the way down to ES3, which would be IE8 support. So as long as you avoid a few things, you can use most of the language today. Your build process just has to have a transpilation step built into it, and away you can go. So that's really close. So you really care about this today. Okay, so without any more introduction, here's what I consider my favorite features of the language. Classes. So if you've ever tried to do classes and prototypical inheritance in ES5 or JavaScript, this is kind of, it's not going to show up on screen. This on the right is what it kind of looks like. And it's really bad because the parent class is not obvious where it is, and it's also repeated lots of places. And then if you have an overridden method and you need to call the parent class inside that, it's also, I mean, it's just code duplication all through. Really big. A lot of people forget that to call inside the constructor to call the parent constructor as well. That gets left out all the time and causes problems. Also, in ES5 constructors, they're just functions, so you can call them without using new in front. So you really should trap for that case and either throw an exception that says don't do this, dummy, or handle it for them. And I'm not sure which is worse, actually, because you're just propagating bad behavior. So this is kind of a mess. So instead they added a formal class syntax. Looks a lot like a lot of other language. Looks a lot like C#, actually. So you can say class name, in this case foo, extends parent class. And that extends parent class, that's the only place the actual name of the parent class has to appear. After that, you can reference it by the keyword super. And so you can just say super. And inside, like in foobar, in the foobar method down there, if we wanted to overwrite, if we were overwriting the parent's foobar method and wanted to call it, we could just say super.foobar, and it would call that as well. So really, really helpful. We officially have a name for a constructor. The keyword constructor now exists, and it works really well. A lot of times, by the way, you're going to hear people call most of ES6 syntactic sugar, which is mostly true, but not completely. And some of these only matter to compiler writers. But for instance, you can't call an ES6 constructor without using the new keyword. It just, the browser will throw an exception. Now, when you transpile it, you totally can do that. So, I mean, you don't gain that aspect when you go down, but there are things that the language enforces on the classes that don't exist in the lower language levels. So it's more than syntactic sugar, but those points are pretty small for the most part. Under the hood, this is still using prototypes and prototypical inheritance. So it's not like this huge new language concept that you're not used to seeing. It's just making it a lot nicer for you to read. So in that case, it is syntactic sugar. Couple other points to point out here. This syntax takes a little bit weird. There's no comma following the closing brace of constructor. It's not a property definition. So that's a little bit different. That trips people up. And also, notice I've got constructor parentheses, foobar parentheses. There's no function keyword in there. That's ES6 syntax. They didn't want you to have to type the word function over and over and over. It's implied, so you just leave it out. So a lot of really nice syntax there. Now, before we just overload, I'm going to stop at each of these. Are there any questions regarding classes in particular? Yes.
Coming from a PHP guide, does ES6 support traits or anything to that effect?
No, there are language specifications out there that would allow that. But the concept of a trait is really similar. I'm not an expert at the syntax in PHP, but from my understanding, it's really similar to a mix-in, and you can do a lot of the same things with mix-ins in JavaScript.
Yeah, and that was, I don't know, I'm curious if you could expand on just the, like, class inheritance relative to prototypical inheritance, because you're saying they're the same thing, but
This is still prototypical inheritance, but this still has a prototype chain. It still works in the same ways.
Yeah, because what I would expect is that prototypical inheritance works a lot more like traits for, like, and I'm not familiar with PHP enough either, but from other languages.
So the big difference is a class can implement multiple traits. It's an interface.
Right.
Whereas in ES6 and in ES5, you can only extend or inherit from one object. There's no polymorphic inheritance in JavaScript. Now you can do mix-in support to get there, another way to phrase this is you can implement interfaces. It's still prototypical inheritance, and so that's there. Other class questions? Yes?
Can you override?
You most certainly can override methods. So in this case, if bar had a method foobar, I would be overriding it here, and if I needed to call it, I would say super.foobar and call it with the correct arguments inside there. So absolutely can override it. No more questions on that? Okay. What's next? Objects. So code ends up getting a lot of anonymous objects, and we saw some of this before, but a lot of the repetition just kind of goes away. In this case, you'll see in the ES6 version, it's just foo, comma. Well, that implies that I was assigning a key and a value that was literally the same string. So that means I'm going to have a string value with the key foo, and the right side is going to be the symbol foo. So don't get too tripped up about that. But it's literally, if you look on the ES5 version, the foo concept, that's what happens. Turns out developers do this a lot, so they added a shortcut to do it. And then the function definition, bar colon function, we can leave the function off, just like on the class. In this case, though, it is an object definition, so we are declaring properties, so there are commas between the properties. So that is different than a class. And this really is, everything you see there is syntactic sugar. There's no change to definition spec. But I find shortcuts like this really handy. Questions on this? That one's kind of an easy one. Default parameters. Thank the Lord. So instead of testing every parameter to see if a value is piped in, and to see whether, if you wanted to pass the value false in, then the test for that becomes a little bit harder than the test for, if it exists, because you can't use a truthy value at that point. So checking for that, and ES6 just makes it mind-numbingly simple. The other thing is to note the second value where opt value equals get val the function. That's evaluated at call time, not at definition. So get val is lazily evaluated when you call the function. So that's pretty crucial to know that. But other than that, they work just like you would expect. I don't have on the list here there's a concept called destructuring. I'm not a huge fan of it. I find it harder to read than the others, but I'll give resources where you can go read about it. But that comes into play with this as well. Yes?
What if you want to pass arguments to get val, including arguments that were passed to foo?
I don't know that you can do that.
Okay.
Yes, you always have the option to still do it inside, just like you used to. And that's a good point, because people often get the point, it was like, well, this is the syntax now, and I'm like, well, all the old stuff still works too. One of the things that got introduced here, which is not on this list as well, what's not on this presentation is like 10 times or 100 times more than what's in it. There's two new variable declaration, let and const. Both are finally block scoped. So if you're not familiar, in JavaScript, a variable or a function is always defined in the full scope, and the scope is defined as a function root or the global script. So even inside an if statement, if you declared var foo, that foo existed everywhere in that function, even if it didn't have a value. So that really tripped up people and caused some real heartache. So there's a let keyword, which is block scoped exactly like it is in other languages. Inside an if brace, inside a for loop, if you declare a variable, it no longer exists when you leave the block. And const just means you're declaring a variable that is assigned at one time and will never be changed. And the compiler and the interpreter in the browser enforces that.
But they're not technically immutable, right? Because if it's an object, you can manipulate the object. You just can't.
It's not the same as immutability. It means you did not change the property binding. So if you assigned it an array, you can still add things to the array and mutate the array, but you can't assign it a different array. Yeah, that's really, really tricky. Also, I don't think you can do constant properties. You can do a variable, but you can still add properties to that variable all day long as well. So you just can't change the initial binding.
If you transpile it, you can though,
Right,
right?
because when you transpile, you lose let and const. The transpiler will do its best to make sure that you're not. Said another way though, the transpiler won't introduce bugs that you would have introduced if you'd used var. So you're safe with transpilation unless you're editing your transpiled code, in which case rethink what you're doing.
You can trick it with an eval statement, which we shouldn't be using.
Right. You can trick it with eval.
Case?
I'm not going to go out on a limb and say that's the only edge case, because JavaScript has so many edge cases that you don't even think of. There would be a lot. I can invent scenarios where JSON.parse might be able to do it as well. Maybe. There's all kinds of weird ones. Anyway, back to this. Any questions on any of that? Default parameters. We got sidetracked on let and const. Okay. REST parameters. So most people, or a lot of people, don't know that this is a simplistic example, but most people don't know that if you pass the arguments object outside of the function, in most browsers, you drop it down into a slower execution mode. So you hit a performance penalty just because you used arguments. So a lot of code bases prohibit referencing the arguments keyword, period, or just ways to get around this. And so there's a general kind of aversion to using arguments if you can get away from it at all. But in ES5, if you need to have a variable number of arguments to the function, you have to use the arguments keyword. There's just no way around it. So ES6 allowed the rest parameters, which is the ellipsis followed by the variable name, which is going to be an actual array of arguments that you can reference. And then you're no longer using the arguments keyword. And it's a lot clearer what you want to do. Yeah, and so in ES5 we had to notice that because we're passing in a variable first, and then we've got variable var args, which is completely unnecessary here. It's only for documentation because we're just dropping down and using the arguments. And in JavaScript you can call any function with any number of arguments, so that's not a problem. But this is weird that we're starting our loop at 1 instead of 0. So you know, any other person that would come along is gonna go, what's going on here? So if we switch to 0 over there, it just makes a lot more syntactic sense. So this is mostly syntactic sugar, except that the variable arguments doesn't incur the performance penalty. Yes?
Do you have to have first, or can it just be .rest?
It can just be .rest, and you can have as many variables as you want. However, it must be the last position. You can't have rest parameters followed by variables. So.
And rest is not a keyword, it could be anything.
It could be anything you want.
And not to steal your thunder, because you may talk about this, but you can use that syntax inside of other arrays too, right? Things like array concatenation.
Right. I believe that comes into the destructuring parameters. But yeah, the ellipsis is used in other places as well. Questions on this? My second favorite feature, arrow functions. So, we use anonymous functions a lot, and they have a number of problems. The biggest problem is this bindings, that you lose your context in an anonymous function unless you explicitly bind it. Or do things like var self equals this and then use self inside as a closure. So there's a couple ways around that, but it's just really not the way you want to do things. So anonymous or arrow functions work very similar to how lambdas work in other languages. Very C-sharp-like syntax, actually, is the way it comes down to. But there's a couple different variations. One, if you have a single statement of the function body and it is an expression that's going to return a value, you can just use parameter name, fat arrow, expression. No even curly braces needed around it. But that gets a little bit confusing to look at, so kind of by habit I put the curly braces just to make people aware that they're looking at a function when they see that. But it's a little weird to people. So this right here is the anonymous function that we would have over here. The other interesting part is all arrow functions have an implicit this binding that's done. How do you describe this? The this binding comes from their definition site. So if you create an arrow function and assign it to like a property and then use it in a completely different function, the binding came from where you created it, not where you are. It's totally the way you would want it to work when you think about it. It just is one of those things that you should be aware of. But this binding allows you to, you know, right here we're explicitly binding, so we can still call this .log in the event handler. Where over here we don't even have to worry about it. We can just do what we would naturally want to do. And then if there's more than one event, you have to use parentheses around the arguments. Or if there's 0 events, I guess I should say if there's not exactly one argument, you have to use parentheses for the arguments. And then in this case down there, it has a single line, which is an expression, so there's no curly braces. But that works. So these work really great for event listeners, array sort functions, any place we need a little trivial callback. I would avoid overuse on, you know, if you're writing more than 1 or 2 lines, you probably shouldn't be using an arrow function to do that. but they are really, really handy. Questions on these?
I frequently have a need to write a function called data, which returns an object of statically defined keys and values to initialize a view component. My question is can you utilize the arrow syntax to get rid of some curly braces in your code?
Oh yeah, absolutely.
Okay, so yeah, I'll probably
So,
teach you later then.
the return is implied. If there's like in this case, I'm returning the result of console.log, which happens to be undefined, but who cares? In this case, I mean, if you have a single line, you can pass arguments in, and you just have a single line that you're returning. Whatever you declared inside there is the thing that's returned. The return is implied. But as soon as you put curly braces in there, then you have to add the return statement.
So, this .log, what is this reference? Does it reference the event object or the
So in this case here, this is referencing fib type. This is a little bit, that's a good question, because this is a little unclear because I'm not inside a prototype and it's not a class. Normally I would not do that in my code. I only use the this keyword inside prototype methods because it's too easy to alias and lose context. But in this case, it's referencing the fib type object up there.
So how do you reference whatever's being passed in then? Is it just, I guess that's just the parameter being passed in?
Right, so it'd be EVT. In this case, right there, it'd just be EVT inside there. Or if on a listener, click listener, if you wanted to get, it would be evt.target to get a hold of, or current target to get a hold of what generated the event.
So besides the change in how this works, is this syntactical sugar? So it's still an anonymous function? It's still
No, it is not. It is illegal. You can't use bind on a arrow function. You cannot reference the arguments object. They don't have one. There's a bunch of edge cases. They are not the same. You'll find places that say they are, but they are not.
Are there any other important differences between with curly brace or not curly brace? Like you said, there's no implicit return with curly braces.
Right.
And obviously, I get the impression that you need curly braces if you want multi-line.
You have to have it if you have more than one line, yes.
Even if they're on one line and semicolon separated? Like what is a line?
We'd have to go look at the spec.
Not that you should ever do something like that. But if you did do something
If you're thinking about putting a semicolon there, then you should use curly braces and put multiple lines. If you're asking the question, you should use curly braces.
Do the arrow functions support argument unpacking?
The destructuring?
Yeah.
I think they do.
Alright. Okay, so in your bottom example in your log function,
Yep.
so you're passing in, I guess, wherever the for each is now an index, right?
Right. So that's the standard arguments to a for each loop, but I'm not using index. But
Can the bodies of the lambda still pull in from the rest of the
absolutely.
okay.
And that's based off the call site, not the definition site, which is different than the this binding. If that was confusing. Yes.
You said we couldn't do a dot bind. Is there any other way to change this, like a dot call?
No, you cannot change the this binding of an arrow function. If you're trying to do that, you shouldn't be using an arrow function. That the biggest, other than it's really fast to write and really easy for trivial, I mean, it's really excellent at trivial things, but the biggest advantage to an arrow function is the automatic this binding.
Could you combine an arrow function with the foo example you used earlier? So I could say data parentheses arrow equals and then some return value.
Right. So a lot of times I just want the this binding, but I have the function already defined somewhere else, and I just don't want to use bind. And so just use an arrow function, and then inside it do this dot whatever to call the function I really wanted,
Sure.
and pass along an event argument. I do stuff like that all the time. It's just so much handier.
Yeah.
Because honestly, dot bind is not great syntax. I mean, it is kind of a pain in the rear. Other questions? I use this the heck out of this in my build scripts, by the way, because it's just, I need a little anonymous function. That I don't even have to think about transpilation at that point because I just say, yeah, you have to have a Node 5 version or newer, and then go. All right. So this actually, this is the thing that I have that gives me the most hope for, but I don't actually use. And here's why. If you're going to add, so if you're using a framework like React or TypeScript or anything that has a compile step before you can load it in the browser, you should use ES6 modules. If you can currently run your code base uncompiled mode, you should not use ES6 modules. And here's why. The ES6 modules introduced two statements, import and export. They are only valid inside a module. They are not valid in JavaScript in general. Therefore, if you try to use them in any browser out there, in any way, they will throw exceptions because none of them support this yet. It's part of the language spec, but the language left the implementation of how to load modules up to the browser manufacturers, and that process is moving very slowly. Whereas, most browsers are at great ES6 support, none of them have this. Not even in nightly builds. I think they just started landing where you can add a script tag, put type equals module and use this in it, but that's about it. So this requires a transpilation step to use in any way. So if you have transpilation or a compile step before you can load it in the browser, you should just go this way. I don't like to wait even 10 seconds for transpilation if I just want to change a style. So I avoid this, and I still use CommonJS modules to do my module loading. But the whole concept here is modules. If you're not familiar with modules in general, there's a bunch of different specs, so they standardize on this. But modules have their own scope. They're not globally scoped, and you can expose certain objects by exporting them in whatever the module specs way. So in ES6 modules, they were specifically designed to allow on-demand asynchronous loading in a browser and synchronous loading, which is what Node.js uses with require. And a lot of times in a browser, people are more familiar with require.js and AMD modules, but their syntax is not often called over-engineered. It's just really not fun to use. So this is kind of the replacement for all of that. It's very easy to go from CommonJS to ES6 modules or back. The biggest difference that you're going to notice is that in CommonJS you can only export one thing. And in ES6 modules, they're designed to work best with a default export. And there's literally the keyword default to put in there to say this is the default object. But you can have as many exports, named exports, as you want in the file. So questions about this?
Yeah, so if I have, say, and I use Browserify to compile all my assets and whatnot, so if I had a module that created a WebSocket connection, and I imported that module into several other different components of my application, it would import as a singleton, right? The same instance imported into all of them?
Yes.
That's magic.
So when you have multiple exports, what is it returning? Like if I import it, do I have to specify which export I want, or is it for an object, or?
Yeah, right up there where I say, down here, I said import bar from there. That's the named export bar. No, I'll have to go look. There's a bajillion variations to this syntax, it seems like. Minor variations. You can import multiple listed things. You can import star. You can import the default.
Well, so like you're exporting foo, but is it just going to be called foo whenever I import it somewhere? You don't
These don't go together. I should have done a better job on that. There's too much to talk about on modules to fit on one screen. But in this point, I'm exporting foo, and that's the named module foo, I believe.
But if you export it as default, you could import it as any name.
So if I put export default foo, then then the top one says import bar, and it's basically an alias. Bar equals food.
Okay.
But everything else in there, so you don't have to worry so much about adding. I always kind of laugh when I see someone's common.js module and they put an IFI, an anonymous function that's immediately executed to protect the scope, because they already had that in place. Modules already protect your scope. So unless you explicitly exposed it through an export, it's not available to anything else. That's what you get from modules. Modules fix the namespacing problem of JavaScript. So you don't have to carve out global namespaces or do all these hoopla to protect things. Modules just make it really, really easy.
And that's, you mentioned import star. Is there like import bar dot star? And like that's.
We can look here in a minute. I'm getting ready to show you great resources that list out all the variations in human readable, not spec readable format. All right. So the fun part about this, the first link on here, which if you want to come up and get this, or we'll post the slide deck, I'm sure. Understanding ES6. Guy wrote a whole book on ES6. You can buy it on Amazon, but his manuscript is freely available on GitHub, and that's his idea. So it's all written in Markdown, and it's great chapters. There's a whole chapter on functions. There's a whole chapter on classes. We're only talking about the syntax things. ES6 introduced new types. There's a map type. There's a symbol type. There's some other things in there, weak map and weak set, things like that. So he has chapters on all of this, which are great reads, and he shows lots of examples of here's what it's like in ES5, here's the problem it solves in ES6, and here's all the little variation edge cases. So that all your questions on modules, all your questions on how all the class syntax, all the things I didn't talk about or kind of at a glance referenced, you can find right there. There are some really there are a couple things in ES6 that you cannot transpile, and one of those is called proxies. So if you're going to use this and want it to work in browsers that aren't like latest, then you should stay away from proxies. Pretty much everything else is fair game in some way or another. Transpilers. For build rules, Babble is by far the biggest option on here, and we'll go do a few fun support work on there. It hooks into every build system known to man. There's grunt plugins, gulp plugins, works in Browserify, works in Webpack, works in with Rollup. I mean, just works. It's not the only one. I work on Closure Compiler. Closure Compiler does transpilation as well. And we'll look at that here in just a minute. And then the last one, what browsers support what. There's a very exhaustive test suite. This is the summary. And you can see which browser versions, like which version of Chrome first introduced which feature. It's a huge table, red, green, yellow. You can click over, hover it over, and get the little comments about what. Maybe it's only supported with a flag. Maybe it's got certain caveats, everything except. So that's a great place to reference as well. Any questions on this? Yes.
Do you know how close any of the browsers are to implementing tail call optimization?
So there's I just read a blog post this last week. Chrome actually put out a big argument about why they have delayed doing that. They're trying to get the spec updated to allow them. One, if you don't know what he's asking with tail call optimization, if you have a recursive function and you call, and the recursion happens at the right spot and in the right format, basically return this with recursive argument, the browser, you can really optimize it where you don't have a performance impact on the stack size. It just keeps reusing the same stack. It's a really cool compiler optimization. Chrome's problem with it is when you open the debug tools, you don't get a true stack trace, or if you use stack trace reporting, with that optimization in place, you have stomped all over your stack, and it's not a true representation of what's happening. So they're trying to figure out how to reconcile that right now. That just came across this week because I've had the same question as well. Okay, let's look. Get out of this. Nope, it does not like being zoomed. So here we just have basically a playground, and it's gonna just work. We can type and see exactly, and their default gives a great example. You notice it gets really verbose over here. There's a lot of edge cases that it's trying to account for. So all those things people said are just syntactic sugar. There's more to it than that going on. But like here, so const temp. So if we go over here, const temp equals return me. So you notice it became var temp. The other thing I should mention out here on Babble is Babble by default requires you to use presets. So, and I think even I've seen people complain about it doesn't come with a default set, but you're going to have to specify which preset you want. There's lots of great examples on it here. This is the ES 2015. Babble is often used to try out new features which may never make it to the language spec. So you may see some cool new thing like async await and want to put it in here and try it, but you run the risk of that may never land in the spec and that may never be there. But Babble will totally work. But yeah, you go to something like this and just start typing code in ES6 format and it'll show you exactly what it's going to put out in ES5. And so these are really fun to play around with. Any questions on this? Concepts in general?
What's the coverage of transpilation on that ES6?
So you have to add polyfills for the types. So if you want to use map, set, weak set, those things, you have to have polyfill libraries for those. It depends on the transpiler whether it will automatically add that for you or not. So you have to check on that. But other than proxies, I think everything can be transpiled. Now, I didn't call it out in the example I showed, but an ES6 class makes it the only way you can add properties on the prototype of the class is with getters and setters, unless you just drop down after the definition and say .prototype . Which you can still do, and it's still totally valid. It's still a prototype. But inside the class definition, there's no properties unless you do getters and setters. And they add a really nice syntax for doing that. So you can say get foo, set foo, just like you would in C# or other languages. Which was kind of a pain in the rear to do in ES5. You had to do object.define properties and define all this. It was not fun. But you can do it really easily. That's not transpilable down to ES3, but it's perfectly fine for ES5. So what that means is, if you need to support less than IE9, don't use getters and setters. That's the moral of the story. Anywhere else is pretty safe. Really good, I think, is the short answer to your question. Other questions on this? All right, then I think that's all I had. Oh, now we did. 2 questions.
I want to ask more about what you do day to day. What kind of stuff do you work on?
Oh, I work on. Well, right now I work on a replacement product for Jack Henry's online banking solution. All written. I work completely on the client side, and we have a whole engineering team that works on API calls, and we make all those calls from JavaScript. So everything I do is in the browser in JavaScript. Large scale application. I have to scale it. It has to be able. The application I'm replacing has 3 million logins a day, so that's the scale it has to go to.
Are you talking about NetTeller?
Yes.
Goodness.
Do you work on NetTeller?
I am the internet banking administrator at one of your banks.
Oh.
So,
How big of a bank?
4 branches.
Okay.
It's not big.
They're demoing it Monday to
Big ones.
the big banks. It'll be demoed to everyone in
Yeah.
October. So.
Like how big? Like.
Has to be $1 billion in assets to be at that. It's the Strategic Initiative Conference for Jack Henry. I'm not going.
Okay, well I don't care. I'm glad that it's coming down the pipe.
You're over a year out before it'll be in a
Yeah, that's
velocity.
fine. Because I have a year's worth of projects to complete a truck before.
Yes.
Barbara, I had a question. Oh, how do you, as the front end team, tool you guys document all your APIs in, do you request the API spec from them? Do they give it to you? How does that?
We have a really cool process. I was telling someone earlier, my team at Jack Henry is very unlike any other team at Jack Henry. We work like a modern startup. When we start a project, and a project can be a small little feature that takes a week to whole new product development, which is over a year long, we create a team with a product team who has done user stories and comps and user testing before we write any code. We have back-end engineers, front-end engineers, and a project manager, and we have an official kickoff meeting. Everyone gets in the room, the product team represents, everyone asks questions, and then weekly sweeps come up. And so there's no API code written until the front-end team and the back-end team agree on the contract, and then they go right to the contract specs.
So I was wondering about Node.js and server-side JavaScript. Do you think that companies and modern places should be giving up things like Python and Perl, things on like, and moving to Node.js for their scripts and their scheduled tasks and automated jobs and things like that? Is it that ready yet?
That's a hard one to answer. So certain tasks Node's not good at. A static file server is not its strength, for instance. You have to do a lot of configuration work just to get it to work, serve a static file system in the same way you can do in like 10 lines in Nginx. I mean, it's ridiculous. If you want to do any type of server-side rewriting, then of course it's going to excel at that. However, it's just tricky because Node.js is single-threaded, and so as you start scaling Node, then if you don't have an automatic scaling mechanism in place, you can get in trouble in a hurry. We're using it. Netflix uses it. A lot of big companies use it as their production web servers, front-end web servers. So yes, it's totally ready if you have the staff to support it. I try not to get too opinionated on what you use back of house because everyone has their own favorite. I really don't care. I live in the browser space as much as possible.
I love it.
Other questions?